आप कम्यूट करते तो ट्रैफिक वगैरह कितना होता होगा आपके लिए?
बहुत ट्रैफिक है आजकल, वो बोलो तो बहुत ट्रैफिक है।
फिर एवरेज कम्यूट टाइम वगैरह कितना लेते हैं आप, मतलब ट्रैवल
तो
करने?
एक्चुअली मुझे मेरा डेली का ट्रैवलिंग होता है 10 किलोमीटर का है। 10 किलोमीटर एक्चुअली होना चाहिए तो 40 मिनट्स में होना चाहिए, और 40 मिनट्स का आजकल 1.5 आवर्स जाता है।
तो ये अभी जो ट्रैफिक की वजह से पोल्यूशन आता है, तो उसकी वजह से क्या क्या प्रॉब्लम्स होते हैं आपको?
तो बहुत प्रॉब्लम्स होता है एक्चुअली मुझे। इतना ट्रैफिक में मीन्स ट्रैफिक बढ़ने से, ये पोल्यूशन का वजह से क्या हो रहा है, मेरा आइज़ में इचिंग होता है, रेडिशनेस होता है, और सवेरे उठते टाइम बहुत स्नीजिंग होता है। और 45 मिनट्स का 1.5 आवर्स होने से ऑलमोस्ट डबल हो रहा है आपका कम्यूट टाइम। इसका वजह से क्या बैक पेन भी हो जाता है, बहुत बैक पेन हो जाता है।
Hello all, this is our topic Best Route Predictor based on pollution caused by traffic congestion. The experience we got after our field visit gave us an opportunity to interact with our potential target users and understand the issues which they face due to pollution and traffic congestion. With the valuable insights from our target users, now we have a deeper understanding of the problem which we have identified. The field visit has motivated us to strive harder for the solution we have proposed for our target users. Insights from target user groups. Our target users include office goers, public transportation drivers, daily commuters. Our interaction with target users gave us a deeper understanding of the problems we identified. The various issues faced by our users were delay in commute, difficulty in breathing due to constant exposure to pollutants, burning sensation in eye, and blurry vision. And this is how we can scale our solution. It can be used by the PUC department to validate whether the vehicle is safe to drive and does not contribute in rising pollution rates. Government can keep a track of the areas with high emission of CO2, and we can notify the users and government officials with the increasing emission of CO2, and also it can be regulated without violation and provide a user specific dashboard interface to check the status of their vehicle and causing harm to the environment.
Hello friends, so this is the centralized dashboards where we are displaying on the basis of how the CO2 emission is dependent on the fuel type and the size of the engine. As you can see on the screen, if the fuel type is Z, basically it is a petrol, and how much CO2 is emitted and the size of the engine. So here are the some of the stats these are the different car making and vehicles making companies and how much they are contributing to the CO2 emissions. So coming to the next. So here in this particular dashboards, here basically these are the companies, and everything here is dynamically changing. For example, I wanted to know the fuel consumption of vehicles built by Ford is, for example, I click on the Ford, so it will show the stats of the Ford. So coming to the next dashboard. So this is basically these are the different manufacturing companies and the models of the vehicles and how much they are contributing in the pollution CO2 emissions. For example, the Charger FFV, it consuming the fuel consumption in the highways is 39.2 percentage, and the average fuel consumption in the cities is 15.15 percentage. So it is basically the comparison between how much it is emitting CO2 on the highway and it is how much CO2 it is emitting in the cities. So coming to the next dashboard. So this is the dashboard where we are comparing the three datas like the average fuel consumption on the highways and the average fuel consumption on the cities and the average fuel consumption on the in between the cities and highways. So this is as the you can see the car manufacturing Audi, the average fuel consumption at the highways is 9.35, and it is the combination where the highways and in between the cities it is 4.94, and the fuel consumption in the cities is 30.79. So coming to the last dashboard, so here as you can see, these are the vehicle class like mid-size SUV, small SUV, standard, full size, and how much they are contributing to the full fuel consumptions in the cities. So here in this dashboards, how the size, engine size is basically dependent on the fuel consumption in the cities. So in the lower section, as you can see, these are the different models of the vehicles and how much they are contributing in the CO2 emissions. Thank you.
Hello everyone, so we are using Dijkstra's algorithm to find the minimum cost path along with the minimum CO2 emission. So in this data structure we are using a graph which consists of the source node, the destination node, and the minimum distance between the two node, and also the CO2 emission in particular between to that node. So whenever we try to run this algorithm, it will find the minimum path along with that which path has the least CO2 emission. So we are using the data structure from the CSV file and importing it, and then we are generating a graph, and then by applying a Dijkstra's algorithm, we are able to get a very shortest part between the 2 points A and B, source and destination, and also with how much the CO2 has been emitted in that area and how we are going to emit it are shown in this by using this algorithm. So just a demonstration of a, so as we can see in that output that the from the source is 778 node and the destination is 226, so the minimum cost distance is 56 kilometer, and the how much the CO2 is emitted and in the entire journey is around 12.5 grams. So that's about the working of the algorithm that we are going to implement in this project.